Good evening, sir. My name is R. Santosh Kumar Reddy, and I am from second CSM C section. My topic is different states of transaction and error handling without inconsistency. The actual question I got is: suppose a transaction T1 starts, performs several operations, and encounters an error before completing. Describe the different states T1 transactions through during this process and explain how the system ensures that T1 does not leave the database in an inconsistent state. Here are the topics which are discussing in this presentation: introduction, transaction states, asset properties, error handling, example, and finally conclusion. Introduction to transactions. Definition: a transaction is a sequence of operations that perform in a single logical function in a database. Importance: ensures that data is consistent and accurate even in the event of failures. Transactions are vital for applications such as banking, inventory management, and online shopping. Transaction is a sequence of operations which also ensures that the consistent and accuracy of the database even after the failures. The next topic is transaction states. There are five transaction states: active, partially committed, failed, aborted, and committed. Active: the transaction is ongoing. Partially committed: the transaction has completed its operations but has not been finalized. Failed: an error occurs before the transaction completes. Aborted: the transaction is rolled back to maintain consistency. Committed: the transaction has successfully completed and is finalized in the database. When the transaction is said to be in active state, when the transaction is still ongoing, and partially committed, when the transaction has completed its operations but not have been finalized, and failed when it occurs an error, and aborted when it occurs an error, roll back to initial stage to maintain consistency of the database, and committed when the transaction is successfully completed and stored in database. And next topic is asset properties. Asset properties: A means atomicity, C for consistency, I for isolation, and D for durability. These properties are very useful in maintaining consistency of database. Atomicity: ensure that all operations within a transaction are completely successful. If any operations fails, the entire transaction fails. Consistency: transactions bring the database from one valid state to another, ensuring that all data integrity constraints are met. Isolation: ensures that transactions are executed independently and transparently. Intermediate results of the transaction are not visible to others until the transaction is committed. Durability: once a transaction is committed, its changes are permanent even in the case of system failure. These operations are very useful to maintain database consistency without any error or misinformation. And next topic is error handling. Handling errors. In a situation where a transaction fails, the database management system must ensure that the database remains consistent. Common reasons for failure include system crashes, hardware failures, or logical errors in transaction execution. And rollback mechanism. When a transaction fails, the DBMS triggers a rollback to restore the database to its previous stable state before the transaction began. This prevents any practical changes from being saved, ensuring data integrity. When error is when the When the error is occurred, the rollback mechanism works. It rollbacks to the previous safe state to maintain the consistency of the database system. We can take an example scenario. Transfer $100 from Ram account to Lakshman's account. Initial balances for Ram are 500, Lakshman are 300. The objective of this example are ensuring a successful transfer while maintaining database integrity. The first stage is active state. Transaction T1 starts and reads the balance of RAM account, which is $500. Next step is deduct $100 from RAM account. Here the transaction is progress and not yet made any changes to the database. It only reads the what is the balance of the RAM account, which is $500. And the next state is partially committed. T1 detects $100 from RAM account, updating the balance to 400. The database update RAM account $400, and the next step is T1 adds $100 to RAM account, which is currently at $300, and the transaction to committed. T1 successfully added $100 to Lakshman account, updating the balance to 400, which Lakshman had $400 after addition. This is the final state. All changes are now permanently saved in the database, which we can say that a transaction is successfully completed without any inconsistency in the database. Here are the final balances after the successful transaction. Ram has $400 and Lakshman has $400. $100 is successfully transferred from Ram to Lakshman. If in case the error is occurred scenario, if an error occurs while trying to update Lakshman account during a transfer, assume the transaction has already deducted 100 rupees from Ram account but fails when adding to Lakshman's account due to an validation error. It states that $100 is deducted from Ram account but not credited to Lakshman account. In this case, what we can do is now below. The transaction is marked as failed due to an error, as it is failed. Rollback execution. The system checks the logs and restores the RAM account back to $500, reserving the earlier deduction. Lakshman account remains at $300 with no changes. When $100 deducted from Ram's account, it the balance is $400, but it not credited into Lakshman's account, which remains at $300 only. So the $100 is back credited into the Ram account because uh, because of Lakshman account. Lakshman has not received money yet. Outcome: the database is now consistent again with no impact from the failed transaction. Conclusion: therefore, the database is in consistent state and overcomes from inconsistent state due to a error in transaction T1. Here are the topics we are discussed in this presentation: introduction, transaction states, asset properties, error handling, example, and finally conclusion. Thank you for listening my presentation. Thank you.